We're asked to evaluate the left and right limits of f of x as it approaches 2. So the notation's kind of subtle here, but that's a minus sign in the superscript position just above and to the right of 2. So that means we're evaluating the limit as x gets closer to 2 coming from the left side. So you want to think about numbers like 1.9. And then think about what happens when you plug in 1.99. What type of y values you're getting when you plug in those numbers that get closer and closer. Well, as you get closer and closer to 2, you're going to get 3 times 2 is going to be 6. 6 minus 9 is going to be negative 3. And the absolute value of negative 3 is going to be positive 3. And now it doesn't matter if you approach it from the left or from the right, but this function is going to be the same thing. And just emphasize that. Let's plug in a number slightly to the right of 2. Well, remember that this is approximate. Take the absolute value of this, and it's approximately 3. Take a number slightly to the right of 2, slightly bigger. And that's approximately 3 when we evaluate the absolute value. So I think that's it for that problem. Let's check out another one here. We have this piecewise function. Now this could be different because piecewise functions can jump in behavior around these points here. X is negative 1. So if we're asked to evaluate the limit as x approaches negative 1, we want to evaluate the limit as x approaches negative 1 from the left over f of x. And if we're slightly slightly less than negative 1, if we're approaching x equals negative 1 coming from the left side, then we're slightly less than negative 1. So that's the behavior of the function is going to be dictated by 2x plus 1. So if you're to plug in negative 1, or if you want to keep that numerical approach, you want to plug in slightly to the left of negative 1. We're going to multiply that by 2, add 1 to it. So we get negative 1 as we approach x equals negative 1 from the left. And now we want to approach negative 1 from the right. If they're the same, then we can say the limit exists. This limit exists. If these are different, we're going to have to say the limit does not exist. So approaching negative 1 from the right, that means a number just a little bit bigger than negative 1. So careful, that's not negative 1.001, that's negative 0.999. That's slightly to the right on the number line. I'm going to copy that to my clipboard because slightly to the right means we're a little bit greater than negative 1. So that means we're doing 2x squared minus x minus 2. So I'm going to square this, multiply by 2, and I'm going to subtract by that number, and then I'm going to subtract 2. So I get something, it's approximately equal to 1, so we can imagine the limit as we get closer and closer is going to be positive 1. Let me see if there's anything I'm forgetting here. It's 2, it's 3. No? So those aren't the same. So we say the limit does not exist. And if you're inputting this answer in Newton, I'm not sure how they want you to enter does not exist. Sometimes programs say DNE, but I have to check that out.